Students, this question was asked in NEET 2024 from the chapter Magnetic Properties of Matter, and the question states that there are two list students. One is list 1 is material, list 2 is susceptibility. In list 1, A is diamagnetic, B ferromagnetic, C paramagnetic, D non-magnetic. And in list 2, chi is equal to 0. Second, 0 is greater than chi is greater than equal to -1. Third is chi is greater than 1, and fourth, 0 is less than chi is less than epsilon, where epsilon is a small positive number. We have to correctly connect the materials from list 1 to the list susceptibility in list 2. Students, what is susceptibility? There are two types of susceptibility, students, you know. One is electrical susceptibility and one is magnetic susceptibility. Magnetic susceptibility. Okay, student? And this is denoted by chi. This is called chi. And students, this is a measure of behavior of a material to an applied external magnetic field. How a material behaves to an applied magnetic field decides its susceptibility. Suppose, students, this is a material we have taken here. This is the material, okay? And suppose this is the applied magnetic field. Okay, student, and suppose this is the direction of the magnetic field. We know, students, every material consists of atoms, and atoms consist of electrons and protons, or the positively charged nucleus and the negatively charged electrons revolve around the nucleus. We know, student, we have studied about dipole. When there is a positive charge and there is a negative charge, and the system of a positive charge and negative charge is called a dipole, students. Okay, so an atom can be considered as a dipole, and due to the unshared electrons, these atoms behave like dipoles, and their alignment to an applied external magnetic field decides about their magnetic properties. And so, students, this chi is defined as M by H, where S is the external magnetic field applied and M is the magnetization of the material, which is equal to magnetic moment per unit volume by external applied magnetic field, and both of them have same unit, student, ampere per meter, and hence chi is a unitless quantity, and this is simply a number as given in list 2. And students, there are various types of, we have seen in list 1, the 4 types of materials are given. Materials can be divided into 4 types depending upon their behavior or how they behave to an applied external magnetic field. Okay, students, suppose this material is made up of several atoms, and so the atoms can be considered as dipoles. Okay, student, a system of positive and negative charges, and they are aligned in different directions, student, randomly. Okay, suppose this is the direction of this and this is the direction. When there is no externally applied magnetic field, they are randomly aligned. But when we apply this external magnetic field, different substances, student, or different materials behave differently. Okay, if on application of the external magnetic field there is no change in the alignment of these magnetic dipoles or the lone pairs of the atoms, okay, student, or the, we may say, atomic magnets, then that material can be called non-magnetic. Okay, it is called non-magnetic, and for the non-magnetic material chi is 0. Okay, student, so we may connect here chi 0 represents the non-magnetic material. And suppose we apply a magnet, external magnet, and all these are aligned in this way in the direction of the magnetic field. This is the direction of the magnetic field, and all the atomic magnets, they are completely aligned in the direction of the magnetic field, giving a positive magnetic field inside and a strong magnetic field, so that this magnetization, magnetic moment, this is magnetic moment per unit volume. They produce magnetic moment because they get aligned, and this is a large number, okay, because all of the atomic dipoles, they are aligned in the direction of the magnetic field, and this m by h or chi or the magnetic susceptibility is a large number, that is greater than 1, okay. So this if this is the behavior of the material, that is called ferromagnetic. Students, we have studied about the ferromagnetic materials. They are iron, nickel, etc. Okay, student. These are the cobalt. These are ferromagnetic substances. And the student, for them, chi is greater than 1. Where is it? Chi is greater than 1. This is ferromagnetic. Okay, student. And if they get aligned opposite to the direction of the applied magnetic field, like this way, if they are aligned like this, student, then it is called diamagnetic. They oppose to the applied magnetic field, and in that case what happens? Chi is a negative number. So student, here I will correspond, II will correspond, or the second will correspond to a diamagnetic. And if some of the atomic dipoles, they are aligned in a weaker way. Okay, student. Suppose this is some of the magnets, some of the atomic dipoles, they get aligned, and most of them are as before, randomly they are aligned. Then this produces a little magnetism in the material, and such materials are called, student, paramagnetic materials, and for them chi is a small number, okay, it is greater than 0, it is a positive number, but it is a small number. In this way, depending upon the response of the material to an externally applied magnetic field, materials are divided into 4 types: non-magnetic, which do not respond at all, or if there is no change in the alignment of the atomic dipoles, then they are called non-magnetic. If they align in a direction opposite to the direction of the applied magnetic field, they are called diamagnetic. If a little alignment, then it is called paramagnetic. If it is the alignment of the atomic dipoles are more, and then chi is a great large number, greater number, and these materials are called, student, ferromagnetic. So we see A goes to II, and B goes to third. A goes to II, B goes to third, C goes to IV. Okay, student, C goes to IV, and D goes to I. So option 1 is correct, student, for this question.